We have here y double prime, or the second order derivative of y, plus the first order derivative of y minus 6y is equal to 2x. This is an example of a non-homogeneous higher order equation. We are going to solve this following the general solution where our g of x is linear. The g of x mentioned here is this right hand side, because if this is equal to 0, then we are just going to use the process involved in solving homogeneous equations, because it will become, or this equation will become homogeneous. But since our right hand side is 2x, which corresponds to our gx, we'll be using this general solution for the solution of this equation. You have here y is equal to y sub c plus y sub p. Now, y sub c is known to be the complementary solution of our equation if our g of x is equal to 0. Hence, we will be using the same processes involved in solving homogeneous equations, specifically the general solutions, which will correspond to our y sub c depending on the roots of our auxiliary equation. Y sub p, on the other hand, is unique when our g of x is linear. Please focus on this given table of particular solutions. Here, we are going to use a second, which corresponds to any g of x which is linear. So we are going to use this equation for y sub p. You will have ax plus b. We will be solving a and b later as part of our process, because we would need the exact value that will be substituted to our y sub b once we have already our y sub c. So let's start with y sub c. In solving for y sub c, as mentioned, we are going to use the same process in solving homogeneous equations where our g of x is equal to 0. Here, it's not 0, it's 2x, but that's the process for y sub c. Hence, we will have here this given equation with differential operator d. We will have here d squared plus d minus 6, and then you have here y equal to 0. After this, you can construct already its auxiliary equation. Hence, you will have here m squared plus m minus 6 is equal to 0. We need to solve for the roots of this given equation, and whatever be the roots, whether they are real or imaginary, or whether there are repetitions or not, we will be using the specific general solutions. We know this is a trinomial expression which can be factored. The factor of this, if I'm correct, is m plus 3 and m minus 2. Because if we're going to multiply that, you will end up with the middle term positive 1m and your last term of minus 6. Hence, our first root is when we equate the first factor to 0, that would be equal to minus 3. And our second root is equal to positive 2. Now that we have minus 3 and 2 being our roots, and they are both real and they are different from one another, we are going to use the general solution for a situation or roots for auxiliary equation where the roots are distinct and real. Supposedly, it should be y equal to something, but since we already have the y here, of course, we can simply label it as y sub c. And it's equal to this form: c sub 1 e to the power of m sub 1x plus c sub 2 e to the power of m sub 2x. We only have two terms because we only have two roots. Now, the roots could be interchanged. Doesn't matter, even if c sub 1 and c sub 2 are also constants, because they are arbitrary constants. So our y sub c is equal to c sub 1 e to the power of your first root minus 3x plus c sub 2 e to the power of your second root 2x. This is your y sub c. So we're almost done, already done. We already have the half of the solution. The next part is for y sub p here. So we need to solve for the values of a and b with actually comparing it to our given equation here. And since our original equation has a degree of 2, so we can come up with the second order derivative of y sub p. The first order derivative is taking into consideration a and b be constants. Ax will just be a and your b is 0. Then your second order derivative is just equal to 0, as the derivative of a constant is 0. So with all of this, instead of our y, second order derivative of y plus first order derivative of y minus 6y is equal to 2x, in solving for y sub b, we'll be substituting this here, and y sub b here. Okay? So please bear with me. This is how we're going to substitute this one. So your second order derivative is 0, this value, plus your first order derivative is a. Okay? Just take note of those situations. Or if you don't want that, you can always add one step. You can have here second order derivative p plus the first order derivative p minus 6y sub p is equal to 2x. Okay, so we still have 0 here plus your first order derivative is a minus 6 times your y sub b, ax plus b equal to 2x. Okay, so simply simplify that. You will have your a minus 6ax plus 6b equal to 2x. The next thing here is to rearrange, or if you want to, your terms on the left hand side so that your terms that will with variable will correspond to will have its corresponding term. So you have here minus 6ax plus a plus sorry, this is not plus, my bad, this is because our multiplier is minus 6, this should be minus, so this is still plus a, then minus 6b is equal to 2x. Now there's only one term here with x, so you pair it with that. This equation will only be true if the term with x will be equal, hence solving a, and the constants are also equal. So you can have this form here, minus 6ax is equal to 2x. How about these two? Since they don't have x term or x coefficient, hence they correspond to the constant on the right hand side, but the right hand side doesn't have any constant, so you can simply say that a minus 6b is equal to 0, because you could also add here plus 0. Okay, so let's continue solving for a here, dividing minus 6x here as well. You will get a is equal to minus 1/3. This is the value of your a. We need that because solving for y sub b follows this according to our table, ax plus b. We still need b. So here, you can substitute now minus 1/3 for your b, minus 6b equal to 0. So you have minus 6b is equal to positive 1/3. So dividing, or you can multiply both sides by negative 1/6. So multiply this here, negative 1/6 as well. So your b is equal to negative 1/18. So with this now, our y sub b earlier is ax plus b. And since we already have the value for our constants a and b, your y sub b is minus 1/3 x minus 1/18, since our b is negative 1/18. This is now our y sub b. So we have y sub b now. We also have y sub c. So this form, simply add them. So please bear with me. I need to memorize that. Minus 3 and plus 2. So you will have here y is equal to y sub c plus y sub b, our solution. Y is equal to c sub 1 e to the power of minus 3x plus c sub 2 e to the power of 2x. Yes, that's correct. Plus your y sub b, which is this. So since it's negative, so we can just simply have here minus 1/3 x minus 1/18. Okay, sorry, I don't have much space, but it should be written in just one single horizontal line. But nevertheless, that is the result. This is the solution for our given equation. We're able to solve both y sub c using the process in homogeneous equations, and y sub p using this particular solution provided by the table earlier. Thank you very much for watching.